Hi guys, welcome back to Super Math for You. This is Mr. Urrego, and today we're doing rational inequalities. We have a rational expression and we have an inequality. The idea is to solve this. Now, we have done polynomial functions. If you haven't seen that, please check this video. Now, in this case, as before, we check for zeros. Okay, we're going to have zeros on the top, and on the bottom, we're going to have vertical asymptotes. When you do the numerator equal to 0, what I'm going to find here are the zeros of the function. So x equals 1 is a 0 of this rational function. When I make my denominator 0, x squared minus 4 equals to 0, what I'm going to be finding, I'll be finding the vertical asymptotes on my function. Okay? Plus 4 plus 4. Cancels. X squared equals 4. Square root. X equals, don't forget the plus or minus 2. And these are my vertical asymptotes. Okay? Now what I do is I do my number line. And I'll show you the graph in a minute. Now, x equals negative 2 here. X equals 1 here. And x equals 2 here. Same process as before. Alright, remember, my first interval comes from all the way from negative infinity, and my last interval goes to positive infinity. So my first interval is going to be from negative infinity to negative 2. And now, because my function has an equal greater than or equal to 0, then I'll be using brackets. Infinity always has a parenthesis. Okay? My next interval is negative 2 to positive 1, bracket. The next one is 1 to 2, bracket. The next one is 2 to positive infinity, parenthesis infinity. I'm going to choose values on those intervals. From negative 2, something that is less is going to be negative 3. Between negative 2 and 1, I can just choose a 0. That's the easiest one. Between 1 and 2, I have to choose something in between, 1.5, and something greater than 2 is going to be 3. Okay, same as before, I'm going to check that in my original function. The first value that I'm going to check is negative 3. Negative 3 minus 1 gives me negative 4. Negative 3 squared is 9 minus 4. Negative 4. 9 minus 4 is positive 5. And negative 4 divided by 5 is negative 4 over 5 greater than 0? No, it's not. So my first interval is false. That doesn't satisfy my inequality. Let's try the 0. 0 minus 1. 0 squared minus 4. 0 minus 1 is negative 1. 0 minus 4 is negative 4. Negative 1 divided by negative 4 is positive 1/4. And that is greater than 0. True. Next value is going to be 1.5. 1.5 minus 1. 1.5 squared minus 4. 1.5 minus 1 gives me 0.5 on the top. 1.5 times 1.5 is 2.25 minus 4. That's going to give me 0.5 on the top. On the bottom is going to give me negative 175. And that's going to be something positive by negative is going to give me a negative number. And negative number is not greater than or equal to 0. So this is false. I can find the answer for this, but I just need to know that it's a negative number. Okay? Be aware of that. I just need to know that if it's greater than 0 or less than 0. So this next interval is going to be false. Let me try the last one. Now I'm going to try the 3. 3 minus 1. 3 squared minus 4. 3 minus 1 is 2. 3 squared is 9 minus 4. 9 minus 4 is 5. And is this value greater than or equal to 0? Yes. What's my answer? These two intervals. So my final answer is going to be bracket negative 2 comma 1 union bracket 2 positive infinity. This will be my answer. let's check the graph. I have two images of my graph. This one is a more zoom into it. All right. So if you remember, my zeros were -2, 1, and 2. Okay. These -2 and 2 were my asymptotes, and 1 was a 0. So this is my first asymptote. That's -2. This is 1. So it's going to more zoom into. So this is -5, -4, -3, -2. Here you have a vertical asymptote. Okay? And then 1 is when my graph touches the x-axis. And then 2 is my next asymptote. An asymptote is a line that my graph will never touch, just in case. Okay? And again, remember, my function had to be greater than or equal to 0, which means it has to be above the x-axis. That means this piece and that piece. If this value is -2 and this is 1, so this piece is from -2 to 1. And now here I have my asymptote, which is 2, all right? And this piece of the graph is above my x-axis. Because if you notice, my graph goes from all the way past infinity and is not going to touch my x-axis. It's going to go like that forever, all the way to positive infinity. And that's how I have this interval. Let's try the last one. This is the 0 of the function. X minus 5 equals 0, plus 5, plus 5, x equals 5. And this is my 0 of a function. Let's go for vertical asymptotes. My denominator. X squared plus 4x plus 4, okay, equal to 0. And this will be the vertical asymptotes. I have to factor this using product and sum. My numbers are 2 times 2, right? 2 times 2 is 4, and 2 plus 2 is 4. So the way to factor this using product and sum, again, if you have questions, I'll link a video about factoring below. And plus 2 here and plus 2 here equal to 0. And now I need to find the values of x. Make this x plus 2 equal to 0. X plus 2 equals to 0 is going to be the same value. Therefore, minus 2 minus 2, minus 2 minus 2. Okay? It's the same asymptote, not changing anything. So, my number line is going to be -2 here and positive 5 there. Same as before, I need to find values. Negative infinity on this side and positive infinity on this side. My first interval is negative infinity to -2. There's no equal underneath. Therefore, my value has a parenthesis, not a bracket. My next interval is -2 to 5. And my next interval is 5 to positive infinity. Choose a value. Something less than -2, I can say -3. Between -2 and 5, 0 is the easiest one. After 5, choose 6. Don't go crazy with that. No need for that. Let's replace those values in the original function. Always in the original function. -3. -3 minus 5. -3 squared plus 4 times -3 plus 4. -8 in the top. The bottom is -3 squared is 9. Minus 12 plus 4. -8. This is going to give me 9 and 4 is 13 minus 12 is 1. -8 divided by 1 is -8. Is that less than 0? Yes. First interval works out. Let's try the 0. 0 minus 5. 0 squared. 0 minus 5 is -5. 0 squared is 0. 4 times 0 is 0. So my answer is negative 5 over 4, which is less than 0. Any negative number is less than 0. That's true. All right, let's try the last one. I'll have 6. 6 minus 5. 6 squared plus 4 times 6 plus 4. 6 minus 5 is 1 on the top. And if you notice, all these numbers are positive. So 6 squared is 36. And 4 times 6 is 24. And plus 4, right? All right. So there's going to be 1 over some positive number, which is going to be 64, I think. Is that less than 0? No. This is a positive number. A positive number is less than 0, so this is false. So my last one is false. Therefore, my answer, and this is going to be a tricky one, guys, okay? Because remember, these two are true. People will make a mistake saying, oh, so my final answer is all the way from negative infinity, right? Which is convert this all the way to 5. All right? Be careful. Even though those are true, you got to remember that your negative 2 value, right, the 0, negative 2 value is not included here. Remember, this value is the one that touches the x-axis, right? But I need values that are less than negative 2 or that are greater than negative 2, but I don't need the negative 2. So when this happens, I need to write the following. My answer is going to be negative infinity, negative 2, right? Because it came out to be true. Union, negative 2, 5. All right? This interval satisfy, this interval satisfy, but because there's no equal underneath, I'm not able to use the value of 2 in between. And that's why I put a parenthesis here and parenthesis here, because I'm not using the value of negative 2. And that's why you go from negative infinity to negative 2. Union, like you jump over the 2. You come from here, 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 here. You jump over the negative 2. And you go here, 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 here. And you don't include the 5 either. All right, so this is my final answer. Let's check out graph. So this is the graph of my function. All right, from negative infinity to negative 2, union negative 2 to positive 5. Now, negative 2 was the value that make my denominator 0, so those were vertical asymptotes. This is negative 2. Remember, an asymptote is a line that my graph will never touch. All right, and the 0 was 5. This is 10. 5 is around here. Because we're not able to see that, let me jump into Desmos. Negative 2 was, here is my asymptote, but now I'm going to zoom in into 5. Okay, I'm going to zoom into 5. Pay attention, guys, to 5. Look at the x-axis, and at 5, my line is going from underneath to above. Look at the right side of 5. My line, my red line, is above the x-axis. All right? To the left of the 5, my graph is below the x-axis. Remember, the values that I want are less than 0. My function, I want the values that are less than 0, which means they are below the x-axis. Below the x-axis is all this part. And in the middle, I have the asymptote, which is there's no graph there, so I have to jump over the negative 2, right? I go from negative infinity to negative 2. I jump over my asymptote, and then I go from negative 2 to positive 5, because at 5, my graph is going to go above my x-axis. Okay, guys, if you understood this, please like the video. That's going to help a lot with the algorithm. And subscribe to the channel. More math coming your way. Thank you again, and till the next time. Bye-bye.